Hi everyone, welcome to this discussion on building chatbots. And okay, what's happening? All right, hi everyone. Can you see my screen? Perfect, perfect, perfect. All right. Yes, I'm the speaker today, Larry. Okay. Before we start, a question from Larry is that how to set up localized DIY LLM chatbots using files in my computer. That's the question that we'll be answering today. And we will go through detailed understanding of the topic. Okay. How does it actually work and how it's going to be? All right. With me is my teammate Shub. Sure, you can turn on the camera if it's possible. And
Hello everyone. Sandeep, I can't start my camera because you have stopped it.
oh, is it?
It's showing that.
All right.
Yeah, sure. Hello everyone. Hope you're doing good.
Okay. Perfect. Perfect. Perfect.
So
All
everyone,
right.
feel free to ask your questions in the chat window, and I and Sandeep will answer the questions.
Okay. Perfect. 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 Okay. So going ahead. Right. So today's discussion topic is it going live on the YouTube? Looks like so. Okay. So today's discussion topic is how to build a custom chatbot from your website's data. This webinar is not a very high level, it's a deep dive. We are going to go into details about embeddings, how does the entire thing work along with large language model, and then we will share with you how to code it up. Okay. So this webinar is fairly hands-on and fairly deep dive. Okay. But having said that, those who are not interested in hands-on or the code, they still can attend the first part where you can get the thorough understanding of how these systems work. All right. As of today, whether you are into sales, into marketing, into content development, into copywriting, everywhere there is an impact of AI. So it's very, very critical for everybody to understand how does the large language models work, how to utilize them, and so on. So the particular thing that we are going to do today is basically go as a deep dive into one of the very critical applications of large language models, which is chatbot. Okay. So, all right. Now, a brief about myself. I graduated from IIT Roorkee in 2002, worked with TE Shaw, Amazon, InMobi, and worked on large-scale computing. I founded a couple of companies, and CloudxLab is one of the companies that I'm running right now. I was also heading AI for a company called Everett. So my most of my past experience has been into technology and machine learning and AI. And yeah, So I enjoy technology. I love explaining it. So that's why I started CloudxLab. Now we will go. This is the brief agenda. We'll talk about LLMs. We'll talk about LLMs in action, how to build the chatbot. We'll talk about RAG, and we'll code it. All right. A brief about CloudxLab. CloudxLab is the core vision is to upskill engineers, IT professionals in deep tech across the globe. Okay, make people future ready. And keeping everything in mind, what we did was we designed our learning environment where the environment is targeted towards hands-on. On the right-hand side, you see the notebook. On the left-hand side is the problem statement. And based on the problem statement, you'll code things in the right-hand side, and then the system in the left-hand side would check whether you have done it correct or not. So basically, you get a consistent feedback loop, right? You can learn all kinds of technologies at CloudxLab. We have courses on fundamentals, everything, Linux, Python, SQL, and data analytics, and machine learning, and data science. So it's a very detailed one. And many people just you take the lab subscription, and with the yearly subscription, everything comes together. You can also, if you don't like this view, you want to use your own way, and you want to directly interact with system, that's also allowed at CloudxLab. So it gives you a real world experience, because the way we have set up the lab is how you will see in the industry. If you're working at a top tech company, you will get an environment like CloudxLab or similar environment where you get a remote access to servers and you'll start working. That's why the lab and the entire learning is stitched towards the real world experience. It's a seamless one because you don't have to download any VMs, you don't have to download anything. You just sign up and get started. Secondly, most of the data sets we have already made available as part of CloudxLab. So there is a central dataset repository and have kept that there. And you can connect from any device from anywhere. And we have the social angles to it. Well, like you have your own profile, you have discussion forum, and so on. And then we have the job portal as well, and where we basically post jobs. Then we conduct these exams called placement eligibility test, where you basically get to display your technical know-how, and then we connect you to the industry. All right. The next thing is that the courses at CloudxLab. So the courses at CloudxLab are basically mostly towards the deep technology part. And you can take a look at the courses at cloudxlab.com. All right. Now, to start with today, first question is, what are the large language models? Okay. Large language models are a recent innovation where the machine has learned to produce outcome based on what it has learned from the internet. The way it has learned to predict the next word given a phrase, and it basically uses that to produce a sentence. So large language models are the recent innovation, though it happened in 2017, but the progress has been continuing since 2017. And recently, after the release of ChatGPT, it is proven that large language models make a lot of sense. It is sort of a true intelligence. Okay. They are designed to produce and process text. They excel in understanding the language and generation. It possesses contextual awareness. The input provided to LLM is called a prompt. Okay. So very important part, what you see in ChatGPT behind ChatGPT is a large language model. Okay, or you can say ChatGPT is one of the large language models. It takes the text, it produces the answer. The way it produces the answer is not because somebody has written a logic that if somebody is asking a question on this, answer here. No, it is producing next word at a time. And then it's combining all of that together. So the chat GPT is probably one of the proofs that large language model is the smartest or the most intelligent system human has ever designed. Of course, there are now competitors, there are many, many others, but the takeaway is the large language models are the first time that basically we are able to create a real intelligence in the history. Okay. So it can even code. It is able to generate really complex code. And you will see that people have started utilizing this large language models in different ways. Okay. Now, today, what we want to do is we want to learn how to build smarter chatbots. So far, what we have learned is that there is a large language model, and it can power the chatbots that can engage in natural conversation, understand complex question, and adapt to different contexts. Okay. Now, for example, using 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 ChatGPT or large language models, you can basically ask for product recommendation, troubleshooting issue, and so on. It can answer well. It can answer many things. Now, but can an LLM answer questions about your company's data based on your company's data? Let's say CloudxLab has some data on its website, and we want to answer the questions of the user about CloudxLab. Can I just ask, can I just ask ChatGPT that tell me what are the courses as of now hosted by, or let's say, what is the refund policy of this particular course? It can't answer that. It can't answer that because of multiple reasons, right? While on one hand, the large language models are very impressive, their knowledge is limited only to the training data. So it is like, can an external person answer questions related to CloudxLab? Even if this person is well-trained linguist, he has an understanding of language, understands languages, and he has understanding of science, and he has understanding of coding and maths, and he has understanding of all sorts of text. Okay, can this person answer questions related to my company? No, right? Similarly, the generic large language models cannot answer the questions related to your company. Instead, if you ask someone outsider a question related to, say, CloudxLab or any other company, what that person will do? That person will say that, okay, give me all your documents, I'll scan through them, and then figure out which part is your question related to, and then I'll try to answer, right? That's what human will do. That, okay, I'll look at all your data, and then, so that's exactly what we are going to do today as part of LLM. If you have private data or new information, the LLMs would not know this new information, or they will not be exposed to your private information, right? Uh, and like, for example, if there's a last week's news, the LLM will not answer it because it has not seen the news yet, because it is trained long back. And why it is trained long back? Because most of the LLMs take long time to train. because they have to go through all the internet's data and they have to go again and again. And that's why there is a that's why it is not possible to retrain it. Okay, retrain it quickly, and it takes a long time. Now, question is, let's say we ask ChatGPT something which is private or which has recently happened is give me summary of discussions on OpenAI Dev Day, right? As per my last update, I don't have specific details about it, and so on. So that's the answer from ChatGPT. So you can see that because of the stale knowledge, it can't answer the question based on which is more recent. All right. Now, in such case, what should we do? In such case, what should we do? Because we want LLM, we want to answer our customer's query. Let's say you want to build a bot and you want to answer customer's query, and large language model doesn't have an exposure to your data, right? As well as large language model is very is having a stale information. Now, one of the thoughts that has been there is, let's retrain the model. Let's retrain the model on my data. And retraining a large language model is next to impossible because it has so many parameters. It requires so much of hardware. Second, it takes long time to train it, right? If you don't train it for long enough and on a big enough data, what happens is that it starts becoming pretty useless. It kind of forgets even the basics. So retraining the LLM on your company's data is almost impossible, because I tried retraining earlier OpenAI models, and when I started, they provide this option of retraining, and it costed us a lot. But what we learned was that after retraining on my company's data, it kind of still became it kind of became more useless. It just kept repeating the same thing, and it could not it kind of forgot what it learned from the internet. So it kind of forgot the fundamentals of language. So if you try to retrain it and you try to retrain it, it might become useless as compared to becoming better. All right, unless and until you retrain it for long duration and so on. What if we provide all our documents in the prompt? Let's say we ask ChatGPT that here are the documents from my organization. Here is the entire knowledge base. Can you answer the question? Right? Sounds good, right? Answer is yes, we can, but there is a problem to it. There is a problem to it. The problem is the prompt or the question that you ask ChatGPT is basically limited. Okay, the size of it is limited. Okay? And like, for example, ChatGPT has maximum token limit of 4096, which is approximately 2000 characters. 2000, not, yeah, approximately 2000 words. Okay, though 2000 words look words, and so our size, the amount of the size of the prompt is approximately, say, 2000 words. Now that's not sufficient, because think of let's say you are a bank and you have details about credit card information, all other products, and so on. One agreement of the credit card document, right? One document on credit card itself will go beyond 2000 words. Correct? So, and this is the largest context window. The largest context window is around 8 1,000 words. Okay. But even that is not sufficient. So what to do in such scenario? Okay. So, and people have tried to build there was one company which tried to build LLM with really large token size, something like 20 megabytes, right? But if you think about it, 20 megabytes is still very small size, token size, right? 20 megabyte means like 10 MB of text that you can pass in the prompt. That is not sufficient because our company's data is in GBs, not in MBs. All right, and therefore, it is all the more reason to research on more ideas. So what we learned so far, number one, retraining large language models, on retraining again is is a uh, is a wasteful exercise because if you try to train the model, it becomes dumber and dumber. Second, it is also costly. Now we can't retrain the model. Now, can I just pass on all the information in prompt? That also you can't do. So what can we do now? What can we do now? Now, how about, you know, how about, yeah, this is another example why the text size could also be a problem. Like, for example, if you give too big a context, it might say that this needs to be made shorter. All right. Okay. Now, also for large prompts, take much longer for LLMs to process, leading to slower response times, and overloading LLMs with information can result in low quality response. So if you create a very large prompt, the other downside of very large prompt is that large prompts are very costly. The GPT or OpenAI charges you based on how many tokens you are feeding and how many tokens you are generating. So the larger tokens you have, the more costlier it is, and also it takes much more time to process for the LLMs. Sometimes providing just too much of information in the prompt kind of drops its quality. Okay, so the question is, how can I build LLM-powered chatbots then? When the prompt size is shorter and training is not possible, then what can we do? The idea is RAG, Retrieval Augmented Generation. Instead of passing all of the documents in the prompt, what if we can pass the documents relevant to user's query? Or we can say required to answer user's query. So if you have, let's say, lots and lots of documents, right? And the question comes, you match with all of the documents and figure out which documents are most relevant or which paragraphs are most relevant. We attach that to the user's question and we can say, ChatGPT, can you answer this question of the user based on these paragraphs? And it would do so. So this is called retrieval augmented generation. Okay, we basically augmenting our prompt, augmenting the question that we are asking to LLM with the data retrieved from our data source. Okay, so this is called retrieval augmented generation. Now, and that's why, because fine-tuning the models is very costly and it's mostly not really advantageous. and prompt size is shorter. So most of the systems that you will see today will be around RAG, the retrieval augmented generation. Okay. So technique for augmenting LLM knowledge with additional data is called RAG. We basically store the data in a knowledge base, and then we retrieve the relevant documents or paragraphs or context from this knowledge base based on the user's query. Now, first stage is that we prepare the knowledge base. Okay, so we need to kind of get all the data from everywhere and then store it. And once we have stored it, then we will basically try to match the question with the documents. Now, question, how do you do the matching? That's a very important part. In the traditional days, we will basically find out the keywords from the questions and match with the knowledge base, and then see which of the documents having these keywords, and we basically retrieve that from the knowledge base. Now, here again, the large language models come to rescue. And large language model has come up with something called embeddings. So a large language model, instead of generating an output, can also be used to generate something called embedding. First, we convert textual data into numerical representation called embedding. And these embeddings are very useful. Now, these large language models can be used to convert this text into a bunch of numbers. We call these bunch of numbers as embeddings. This is the most important concept to understand. That what exactly is embedding? Embedding is numeric representation of your text. It is not like a one-to-one mapping saying this word means 1, this word means 2. No. These numbers do not carry meaning of its own. Instead, these numbers are mostly relative, right? Like, for example, when we feed a text like canine companions say, and this will, instead of this large language model, instead of producing completing the sentence, it will basically, we are extracting these last layer of the neural network called an embedding. This is what we get from the large language model. So this is essentially another use case of large language model. Instead of producing text, it can also produce the numbers. Okay. Now, what is cool about these numbers? Individually, these numbers would look very random. They will look like this bunch of numbers. They may not make sense. Like, for example, if you feed empty string, do you expect it to be zeros? Right? No. The answer will be, even in the empty text, this would come out as zeros. This will come out some random numbers. Or you say space, comma, space, comma, space, comma, space, that would also come out with some numbers. Okay. So individually, these numbers do not make sense. How then, what is the use of these numbers? Now, the coolest part about these numbers is when you plot them, you will find that similar things would end up looking or end up getting together. For example, canine companions say woof, right? This is very close by. Okay. Right? The wolf or the dog is a canine, right? Now, feline friends say meow, right? Which is, you can see that these are close together. These are close together. Now, there is another sentence, say, a quarterback throws a football. A quarterback throws a football. This sentence is far away from all of them, correct? So similar things produce numbers which are nearby. Very different things, very different text produces numbers that are far away. Okay, so this is called embeddings. Embeddings means that this is basically semantic. Semantic means meaning of a text, right? Syntactic means actual word. When we say two things are syntactically similar, it means they carry the same number of characters, same number of words, or similar number of words, right? When we say something called semantic means they carry similar meaning. So canine companion say woof. These two sentences or two phrases are similar. They belong together. Bovine buddies say moo. They belong together because they are nearby. So that is the magic of embedding. Embeddings, which are a bunch of numbers, when you plot them on a graph, they turn out to be nearby. Now you might see that this is having 15 numbers, like 1500 numbers. These will be 1500 numbers. Here we are plotting on XY plane, which is 2D, which means two numbers to represent each of them, right? So we basically reducing the dimensions and plotting it. But just to drive to the idea, when you plot these things in multidimensional space, they will be close by. All right, they will be close by. Now, similarly, here is another example to give you a visualization. Lion, cow, wolf, cat, dog, they kind of belong together. While kitten and puppy, they are also belong together. Now, these and these things should be closer, while these things are far away. These are vehicles and so on. Now, why is there a distance from here to here? The reason is that there might be a z direction, like the third the dimension from which this will be close by. Okay, so this will be close by while they will be far away. So you can see that things which are similar in nature, things that are similar in nature, they would end up together if you compute their embeddings and plot them. Okay. Now, this is the magic of embedding. At first, these embeddings would look random, but when you plot them, they'll turn out to be useful. Now, they can be used to do the sentiment analysis and so on. The embeddings have lot many use cases. Using embedding, you can generate the recommendations for a product. You can do lot more things. Okay, so we did this sentiment analysis webinar earlier, which was around the embeddings. Okay. All right. Now, the benefits of embedding is that you are able to, the benefits of embedding is you are able to find out similar documents. Okay. If you do the word by search, what else could you do, right? Given a question, we have to find out which document is matching closest. One way could have been that, okay, let's just find the frequency of words in this question. And then we have frequency of words of every document, and then we match it. Just like any enterprise search software used to work earlier, right? So you'll basically do the keyword analysis, prepare indexes of every document, that this word has come this many times in these documents, this word has come this many times in these documents. We have this list of things, right? List of index. And then when somebody is looking for a question, we'll look at, okay, each word we'll do, and then find out where all that's existing. And then that was called the syntactic, based on the syntax, based on exact word, not based on the meaning. Because in real life, each word carries a different meaning. Like, for example, queen. Queen, if you say queen in context of a movie, then it's a movie, right? If you use a sentence, hey, have you watched this movie called Queen? How was it? Right? Here it's very clear that this Queen is related to movie. It must be a movie name. Now, if you say, I was playing the cards game and I got the Queen's card, right? And then will be, if you say that, hey, have you heard the music by Queen? And you say, okay, it's a music band. So Queen could be a movie, Queen could be a music band, Queen could be a card from the from the playing cards, and Queen could be the Queen of England or Queen of some other country. So there are, same word could carry hundreds of meanings, not hundreds as in tens of meanings. Okay. Now, when we did the syntactic search, when we look for the word queen, and you end up in the documents. That never worked. That was not as good as based on the semantic similarity. Semantic similarity, the two sentences are very far away. If you try to plot the two sentences, like I was playing the game of cards and I got queen, okay, and the other one says that I was watching this TV series called Card of Games, and the life as a queen of a particular kingdom would be like the life of like the cards. Now these two sentences will be far away. One talks about the queen in the Queen of England, like in the historical sense. Other talks about queen as a card game. Now these sentences syntactically they may be similar, but semantically they will be far away. Now that is the purpose of the semantic search. Semantic search is way better, and semantic search is done using embeddings, right? Here is another example that shows that if you compute the embeddings of how old are you, what is your age, my phone is good, and then find the distance with each other, you will see this kind of relationship, right? This is very important, everyone. So we converted them into numbers and then found the distance between this and this. So you can see, how old are you? How old are you? This is exact. So this is darkest. Okay. How old are you? And second one is, what is your age? This is still somewhat related, right? And you can see this is red. Not related, it's like very much related. So you can see that these are, when you compute the distance between these two, you'll find that this and this, what is your age and how old are you, are very close by. But if you say my phone is good and how old are you, they have no relation. So the distance will, this value, when you compute the distance, like a Pythagoras distance between these two, this will come out to be very small, very large. So there will be a very small similarity. Okay. And then how old are you and your cell phone looks good. So this is again very far away. It has no relationship. Now, but if you see my phone looks good, my phone is good, and your cell phone looks great. You see this number? This is red. Okay. These two sentences are different. It talks about phone and it talks about cell phone, right? And this says good, this says great. Now, even though it says my and your, but the sentences are very nearby, correct? So even though each word between these are very different, still the meaning is same. That is the power of embedding, because large language models understand language, so they are able to produce numbers which represent the meaning of a sentence. Okay, so large language models produce embedding, and embeddings are basically a bunch of numbers, and those numbers can be used to do semantic similarity. Okay, I hope everybody's okay so far. All right. First, we convert the textual data into numeric representation called embedding. And then the next part is we store these embeddings into this thing called vector store. Now, what's the quality of vector store? Vector store basically indexes these embeddings such that the embeddings which are nearby, they'll come together, and the embeddings that are far away, so it kind of creates these groups of embeddings, and it creates subgroups and subgroups and subgroups of these embeddings, such that the things that are similar, they will come together. So vector store kind of creates a tree of these groups, okay, so that you can find things quickly. Just like you find the address of a particular country quickly, like you first divide the entire thing into entire country into states, or in the world, you first divide the world into countries, and then you divide each country into a state, and then each state into city, and in each city you put it into lanes, and in each lane you put it into the house number, right? So just like that, vector store, what it does is it takes the embeddings and start creating these groups and subgroups and subgroups, subgroups and subgroups. And when somebody is looking for a particular embedding, so what it does is it basically goes into subgroups and gives you the nearest neighbors for that particular address. Okay, so that's called the algorithm called k nearest neighbors. So it gives the nearest neighbors to that group, that particular address. Now, so vector stores are basically the storage is servers, where storage is software, where you put in the embeddings. Embeddings are a bunch of numbers, and it organizes them into some hierarchy, just like I described about country and states and city and streets. Similar to that, it kind of breaks it down into groups and groups, so that while looking for an embedding, it becomes faster. So specialized databases designed to store and manage high-dimensional vectors representing textual or multimedia data. They are basically designed for storing high-dimensional vectors. And the way it does is it keeps creating groups internally, and that's what we call it. So that's how it does the optimization. Okay, so it's optimized for fast retrieval of similar vectors based on their numeric representation. Benefits of a vector store is lightning fast search, and it's scalable, and it provides dynamic updates. I'm calling it vector store. Some people call it vector databases, but database is such a big name because a database provides hundreds of more things. Okay, so most of the systems don't deserve to be called databases. That's why I call them store. Okay, so it's kind of a vector store, not vector database. Okay, but as a matter of choice, you will hear both the words interchangeably: vector database and vector store. Okay, now it's pretty useful. There are quite a few. There are commercial ones. There are free ones. Just search for vector stores. You will find great set of softwares. Now, how do you create the knowledge base? You take the company's data, you crawl it, you break it down into paragraphs, and then convert it into embedding and give those embeddings to vector store. Okay. All right. So this is a company's data. It could be PDF, it could be HTML, it could be text, it could be docs, and it could be inside Google Docs. It could be on some other data source such as Dropbox or Google Drive. So you basically extract all the information, break it down into paragraphs, or break it down into pages of data, pages of text, feed it to the embedding, feeding it to the large language model. Large language model converts that into a bunch of numbers and gives it to the vector store. Vector store takes those numbers, keeps a record of which document is related to which embedding, and organizes embeddings into groups and subgroups. Okay. Now, we will use, once we have prepared this knowledge base inside the vector store, we will use vector store to answer users' question, right? We will ask vector store, give me all the pages that are near to these embeddings. Okay. So when the user's query comes, you ask the embedding model that, hey, give me the embedding. It gave me the embedding. Now I take these embeddings and look up in the vector. We can we ask the vector store that here is my embedding of the question. Give me four nearest neighbors. It's like, you have the story like Google Maps that is containing all the addresses, right? And then you are giving it one particular address. It is looking up into that state, that country, that into that city, that lane, and nearby four neighbors it is giving, right? We call that top K. Similar documents. Here we are. This K is configurable based on your prompt size. You can decide upon that. So it gives you four, let's say here, K nearest documents, which are similar to the question that user has asked. Okay. And once you have done that, we go ahead with, once we have done that, then right. Yeah, let me go back. Yeah. So basically, the embedding model of vector database will give you the documents that are needed. And once we have the context, we call this as a context. Okay. All the documents that we have gathered, which are related to the user's questions, the top four documents, what we'll do, we will put in the user query. We'll say, here we'll tell LLM that here is a question from user. Can you answer this question based on this context? And this context is paragraphs from the vector store. Similar paragraph that answer this question. And then the LLM will generate a response. Okay. Now the entire thing is put together. So you have company's data, you ask the LLM to give the embedding, took those embeddings and put it in the vector store. When the user's question comes in, you basically ask the LLM to generate the embedding. Then you look for those embeddings in the vector store, and then it gives you relevant documents. Then you prepare the prompt and then ask the LLM. So this user query combined with the context that you got from here, that is basically the relevant documents. And then you ask the LLM that here is my question from the user, and here is here are the documents. Can you answer it? Then it generates the answer. We give it to the end user. Okay. Now let's start coding from here. Let me see. Shubh, are you ready?
Yes, Sandeep.
So
Uh,
is there any question that I need to answer before we go ahead with coding?
yeah, you can open the Q&A window. There are some good questions which you can answer.
Okay. First question is, can we build an AI chatbot for lead generation? If so, please tell a brief roadmap to build it. Good question. So I think, probably, what do you mean by lead generation? Lead generation means that for your product, you want to find out the contact details. Probably you will have to, this is something that I am not thought about. Probably you can search the LinkedIn or so, because for lead generation, you have to get some database of people, and the LLMs do not keep the database of people. At most, what you can do is you can ask ChatGPT how to generate leads in your specific domain. It can give you the sources of people, such as could be go to LinkedIn or so. All right. Can you re-explain more LLM? LLM is large language model, and it's essentially kind of the way you can think about model, right? What is a model? Model is the weights, or you can say model is some sort of a automatically learned brain. This brain has been trained based on the data. Okay. So when I say train the brain, it's essentially, tweaking the knobs, I call it. That there is neurons, there are weights, so we keep on tweaking in until we get the correct answer. So So basically, you can think of the model as a big bunch of numbers that we try to figure out based on input and expected output. Okay. Think of, when you take bath, you tweak the knobs of the taps until you get the best water, right? Same way, you can think of large language model as, say, let's say 10 billion knobs that you have to tweak in order to get the desired next word. So what LLM does, the LLM training does is when you're training an LLM is you get all the data from internet. And for each phrase, you try to predict the next word and you do it over and over for all the data, right? And in the meantime, in due course of this feeding the data, these knobs that I said, tens of billions of knobs, will be tweaked by the computer so that the next word prediction can be done properly, right? So this is a large language model. A large language model is a model learned from large language text. Okay. Or you can say it's a large model which is learned to produce the next word based on the previous set of words. Okay. So that's why it's called large language. It consumes language, it produces language. The other use case of large language model we found is that it can produce bunch of numbers and internal numbers we extract from the model, and that's what is called embedding. All right. Are questions we ask to ChatGPT in general embedded automatically? So yes, in ChatGPT, what happens, the way you can think of it is that basically there are layers of neurons. Okay. The way we have designed these systems is like we've kind of taken analogy from the human brain or animal brain, where you have neurons, which has the connections. So we basically, these connections is what we make or build in order to produce the outcome. So, and so first layer of outcome goes to the second layer's outcome goes to third layer. Like that, there are millions of layers. Okay. And essentially each of layer, you can think of it as if some sort of mathematical calculation, addition, subtract, multiplication going on here. And that next one is being produced. And in the meantime, these connections are happening. Now, these connections basically are something called weights that is part of model and so on. So the normal LLM, when it takes the text from you, when ChatGPT takes a question from you, the first layer translates into some bunch of numbers, then second layer takes it and converts to another bunch of numbers. Like that, it keeps on translating them until it produces the actual word you are looking for. But just before the last layer, all the numbers that are generated is what people extract them and call them embeddings by a bit of pre-processing. Okay. Is there any deep learning or NLP knowledge required to completely transition into Gen AI? And what about function apps and cloud services to create end-to-end chatbots? What tech stack is required specifically? There could be multiple tech stacks. Okay, there could be multiple tech stacks. If you are a full stack engineer, you can use any of the tech stacks. And that's why we wanted to do this today's webinar, that you can use any of the tech stack. And we just talk about the entire underlying philosophy. And this current one we have implemented using Python, and we are using a framework called LangChain. And of course, after you build it, it's up to you whether you host it at your place or you want to host it on the cloud. Okay, cloud is nothing but computer at somebody else's place. So it's important for you to know how to use it. Now, the other important part to know is that Microsoft, Google, and others, they have started creating these nice services which you can utilize rather than coding everything from scratch. In this tutorial, we want it to be the cloud agnostic. We want to be independent of any of the cloud providers or anybody. Therefore, we have not specifically put them here because otherwise it look like that we are marketing for Google or Microsoft, right? And therefore, my suggestion would be that once you know the underlying philosophy, the one that we're talking here, you will be able to utilize any of the offerings by any cloud services. Now, a bit of knowledge is required of Python and basics of machine learning. That's why what we have done is we have launched this course on generative AI, and it'll be a hands-on course for engineers. You can take a look at that. So LLM will read the whole selected context to answer the query. That's correct. It'll read the it'll use the selected context and the question to answer the query, not entire text. Reading the whole doc and preparing this knowledge base is not the role of LLM. This is something that you have to do. So it is something that engineering team or engineering frameworks have to do. Okay. Can you people go over the last diagram once more? Yeah, this diagram. Okay. So this is your company's data, right? You take the company's data as in one document at a time, or one paragraph at a time, and you convert that into bunch of numbers called embeddings. We store that in vector store. Vector store indexes that data by grouping the data together and creating subgroups and so on. And then when the query from the user comes in, you take that query and then ask the large language model to generate the embedding, and then take that embedding, go to vector store, and then vector store gives you relevant documents. Okay, so you got the relevant documents, you got the user query, then you ask large language model that can you answer this user query based on these documents, and then LLM would give the response and you give it to the customer. Of course, this is very, very high level. There are lots of nuances in this, and there are lots and lots of work that needs to be done. Okay. All right. So I hope that answers your question, Satyam. A question from Guru Nathan is, are questions we asked to ChatGPT in general embedding? Okay, this one I have answered. All right. How can we store vector store in persistent database, which free DBs and tools? You want to answer this question, Shubh?
Yeah, sorry, which one?
Some examples of the vector stores.
Yeah, so like there are several vector stores hosted, for some, like one is Chroma, which is free and open source. There is also Milverse, which is free and open source, but it also has a paid version for the enterprises. Pinecone is also a good one, so but it's paid. So you can like choose according to your purpose. Like if you want a free and open source version, you can either go for Chroma and Milverse, and if you want a paid version for support and everything, you can go for Pinecone or Milverse Premium. So
Yeah. There is one from Facebook called FAIS, Phase. That's also pretty good. You can take a look at that. All right. Thank you, Sub. A question is, if my corporate data consists of text as well as relational data, how do I embed the relational data alongside the contextual data? Good question and a hard question. Okay, so there are two ways to handle the relational data. Number one of the techniques that people were looking at was that if a tabular data comes in, you can actually convert it into Markdown and generate the embedding. It actually works, right? So that is one way, first way. Second way could be that you take this data, let's say it's a big table, right? And put it in a SQL environment and try to generate SQL query using the LLM and then query this data. That could be another. The third could be that you ask the LLM to take this table and ask LLM to describe this table and use this description for querying. Okay, so those are a couple of ideas. Depending upon the kind of data, kind of problem statement, you can basically handle that. All right. A question is there a possibility that LLM retrieves answer from other trained data that are similar to our data? Is there a possibility that LLM retrieves answer from other trained? Okay. No, you will be looking up in the vector store when you are searching for nearest neighbors. It is you who is searching, and it is you who has prepared the vector store. If your data, it will be basically the search is happening only on your data, right? But if let's say LLM is not able to answer a question using your data alone, it would try to utilize its own knowledge. All right. A question from Satish says that LLM models like transform models are pre-trained models with their own data and they have limitations of tokens. Can you explain how can we create the data set on top of? Yeah, so that's what this talk about, that LLM models. So there are basically transformer. When you hear the transformer is a structure on before when you create the structure using transformer, it is like saying that it is a neural network, right? You have to take a neural network or which is organized like a transformer. You take this and train it. Okay, so there could be hundreds of different kind of transformer models, but the large language model is the one which is based on transformers, but it is trained on the data, on large data, and it understands the language. Okay, now the right. So that's what the talk was about. That if the prompt size is small, you cannot give the entire data. You augment it. All right. This diagram is what it is. All right. Question from Anmol is, Sandeep, for K means to determine the proximity, you need to give the seed value or bucket size. Okay. Based on the search output of matching the document, maybe coarse or too small, how do we decide the seed value? Yeah, good question. Question is, so there is a proximity value. So what you do is usually you basically decide upon the number of contacts. Okay, so what you do is question is, how do we find k relevant documents, right? Essentially what you do is you say that, okay, now these k relevant documents could be such that pay attention to this. Let's say somebody asked completely irrelevant question which is not at all in the vector store. In that case, these k relevant documents will be completely meaningless, right? Therefore, you have to keep a particular threshold that if the matching is below this, don't give any answers, right? Now, question here is that how do we decide that threshold, right? One way to do the threshold decisions is that take a look at the question and take a look at the question and do a bit of matching to take a look at each paragraph in your company's data and try to match it with every other paragraphs. Okay, that way you will be able to figure out, like if you do it for let's say 20 paragraphs and look at all the data, you will be able to look at like what is the safest threshold. Okay, so threshold computation is a bit of exercise that beyond this must match, don't give any answer. It's okay to not give any answers. It's okay to give that document not found rather than irrelevant documents. Correct? So yeah, so first you have to do a bit of exercise, looking at your data, looking at the distance that you're using, and based on that, you'll say, okay, below this threshold, we are not going to go. Okay, even if we are not able to find the documents, it's okay. Second is, how many documents should we give? Like what should be the value of K? The value of K is a function of how big a window size you have. If you have, right, if you're using a model which is good enough and can hold multiple paragraphs, then you can go for K equal to 5, 6, whatever fits your prompt size. I hope that answers your question. All right. The embedding looks straightforward and generates the numeric data. What is continuous learning for LLM. The embedding looks straightforward and generates the numeric data. That's right. What is continuous learning for LLM? The continuous, when I say continuous learning, let's say you want to say that, okay, this model need to keep on updating and we need to do it. So here we have to continuously keep on getting the company's data. Also, when this company's data changes, you have to keep deleting and updating again. And this is essentially what is called continuous integration here. Okay. A question from Ramesh is, I possess a business document consisting of approximately 1600 pages, commonly referred to as help document. I aim to train a large language model with this material. What would be the most suitable approach for this purpose? Fine tuning or utilizing RAG? 1600 pages is nothing for an LLM. Okay. If you had 16 million pages, I would recommend going for retraining or fine tuning, and you have lots of money for buying the hardware or cloud hostings, right? But if you want to go for 1600 pages, I would strongly recommend go for RAG, okay? Retrieval augmented generation. How to incorporate data governance in the procedure. Basically, I want to understand how simple or complex is it to set up the required tool. Okay. Yeah. So I think that is something that someone else can answer. I do not have the, because I have right. I would have a different definition of data governance. Okay, and this is more about processes. So something probably I'm not the right person to discuss that. Okay. If that is the case, what is the need to embed the question as well and pass it to the Lord as you had just shown? You mean to say here, right? What is the point of embedding the user's query and asking the LLM? Let me see. Yeah. Gurunathan, you can talk. I have allowed you to. Okay. So
So
you
my
need,
question was, if all the questions that we ask a LLM are typically embedded by itself, in our use case, why are we
no,
also
so
trying to embed the questions?
no, so embedding here has nothing to do with the keyword embed. Okay. Embedding is also sometimes called as activation. Sometimes it's called encoding, right? So basically, let's say there is a company's data. The purpose of embedding is to find the relevant document, right? Now, these documents are being used to prepare the prompt. So you have to put the user's question. What is that question we want to answer based on the context? So when you asked, right, that is the question embedded? No. So this here in the embedding layer, like we are storing company's data. So we have stored all the documents. When the user's question comes, we don't store it in vector store. Instead, we just search for it and then we get it. Okay. So these documents that you're getting do not contain the user's question. Did I understand your question correctly?
Yes, but earlier I also asked a question, if all the text that we pass to a chat GPT model for LLM or what, so the way, like, let's forget this use case for a second. Let's say I ask how to make a pizza, right? It has the knowledge from the web based on trillions of words of data, right? So it is going to embed my question, how to make a pizza, and then that is how it is going to do the search, correct? So
Mm,
in
so are you saying that the answer will contain the question? Of course, yeah.
so basically, whatever question I ask chat GPT, it is going to convert it to numbers
Yes.
or encode it in some way so that it
Yeah.
can match to its data model to answer my question and to give a prediction of the
Right.
next word.
Correct.
So in coming back to our use case, you are taking the company's data and
Right.
embedding it and storing it to a vector store. That part is very clear, right?
Right.
So you are saying the user query should also be converted to a embedded and then stored in a vector store,
No,
right?
that's not. No, that's not being stored. It just searched.
Okay. But my point is, why should we again do that embedding? Like I'm talking about the one arrow before that arrow.
This one.
Yes. So if LLMs can automatically do it, can't we just pass the natural language text to LLM with
Right.
the context of the embedded documents?
No,
But
but you have to first find the relevant documents.
I see. Okay. Even to find the context, you need the questions to be embedded.
Yes. Yes.
Okay.
Yes.
Got it. Got it. Okay. 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 All right.
right.
Okay.
All right. Cool.
Thank you.
All right. A question from Anupam. Thanks, Sandeep. Are there security concerns of the companies using internal documents and these are loaded to the servers here? What are the alternative or mitigation for that? Like here, yeah, when you are taking, let's say, company's document and putting that into a store, like vector store, what is happening is that the company's data is getting converted into some sort of embedding and kept it here. Now, this vector store can be on third-party systems such as Pinecone. They could be on your own cloud, a dedicated server for on your own cloud, or they could be inside your system. Now, depending upon where you keep it, the security concerns will differ. Now, next problem actually arises when the user's question comes and you are going to look it up. Now, what you're going to do is based on the user's query and the context, you're going to give the answer, which means if this documents that you searched contain the proprietary information that you don't want to expose to public, then they'll get exposed to LLM and also the user in the end, right? So what to do in this scenario? What companies or people do is they, while generating the embeddings or storing in the vector store, they eliminate personally identifiable information such as name of the person, places, and so on. So what people usually do is they use something like named entity recognition, and which recognizes that this word is a proper noun. So you may want to replace it with some other word, or you may want to mask it, and then you store it in the database. So when you are producing like this, like just like newspaper does, that they change the names, so you can basically just change the name while storing, and retrieval, it will also produce some random names. Okay, this is for avoiding the confidential information. Maybe you don't want to give exact numbers and so on. So there are dedicated machine learning models which are designed to translate confidential information into some other numbers, text, and so on. Okay. Last time in the last webinar, we talked about data synthesis, right? So take a look at that. All right. How do we build our multimodal based on a particular LLM? So similar technique is again used. The retrieval augmented generation is again used for the multimodal. LLM understands only text or it understands images as well. Some of the newer models have started understanding images, but again, the amount of understanding it has about the text is way higher than the images. Okay, so yes, even in that case, you will have to basically find, snippets of images which are similar to your questions, and then you will have to look at that. Now, question is, how can we break down a high-level question into smaller parts and get the LLM to compose a procedure to prepare a final answer? Yeah. So you can look at Shantanu, you can look at something called chain of thought. So there is a very popular strategy called chain of thought, which basically first question is generating the prompts for itself, and then next prompts are generating the prompts itself. So it kind of goes in a loop, and sometimes it gets stuck. So slight bit of strategy there. So take a look at chain of thought. Okay. All right. So those were some very good questions. All right.
Okay, so I can take it from here, the coding
Yeah.
part.
Yeah.
So the questions were really good and like they kept me going. So if I there were lots of questions. If anyone's question is left, they can again ask using the Q&A window or chat window. And so yeah. So now we will like discuss about the code part of the chat GPT. So sorry, the code part of the RAG. So let's see how we can like code the RAG system so that we can build a chatbot that can answer on our website data. So I'll share my screen and start with the code part. Yeah, so for easiness, I have put the code here. So I'll also share the link in the chat window, so you all can like be with me. And let me also share it in the YouTube chat.
All right. Bye-bye.
Yeah. So like this is the like a code for how to build a custom chatbot from a website that is using OpenAI and LangChain. So I've also provided a setup instructions for you all. So you just need to clone this repository, and you need to then create a virtual environment so that the project doesn't get involved with your other projects, and there is no dependency conflict between your this project and other projects. So that's why we create a virtual environment so that this project gets isolated. And we would like Python 3.10.11 to create the virtual environment. So you can use the same so that you don't get any conflicts or issues. And LangChain also only supports Python greater than 3.10. So you'll have to like use Python 3.10 version or any higher. So then you will need to activate the virtual environment and then install the requirements file. In requirements file, we have mentioned all the packages which we will be using in the chatbot. And then there is an environment sample.sh file. So you simply need to rename it to env.sh. And this is for Linux users. For a Windows user, there will be a .bat file. So you will have to like rename this file from sh extension to bat extension. This may work good for Mac and Linux, but for Windows, you will have to like use .bat extension. And here also, instead of export, you will have to modify it for set like it is a set keyword. So in Windows we use set keyword for here. So this is the OpenAI API key because we will be using the GPT 3.5 model for our purpose, and you can like set the value from here. So and then you will be like configured with the environment, and you can like easily go through the code. So yeah, let me just okay. Yeah. So this is our requirement file. So we will be using these packages for our chatbot. So we will be using LangChain and LangChain OpenAI. So LangChain OpenAI is a separate package to interact with OpenAI package with LangChain. Then we have BS4 and HTML2 text. So these are packages required for the web crawling part. So that when we will crawl the data from the website, so these packages will be used there. And then we use the ChromaDB. So this is the vector store which we'll be using. So we will use the free and open source version of Chroma. So this is the vector store which we will be using. So yeah, so first we will start with getting the data, because that's the first step of the process. Like first we get the data, then we convert it into like clean the data, pre-process it, and then we convert it into documents, and then after that we convert it into embeddings and store into the vector store. And then we can use that vector store to retrieve the document based on the user's query. So let's first start with the web crawler file. So I have like already cloned the repo and set up all the things. So I will not be needing that. So this is the function which by using which we can like crawl the data. So like it retrieves text content and metadata from a given URL. So you just pass it a URL, and see, first we will discuss it function by function, how a particular function works, and at last we will like sum up all these functions and see how they can work in union, and how an end-to-end system works. So first of all, we request the URL from the server so that we can receive the content for it. So then we use the beautiful soup library, BS4 library to like parse the content into HTML content. So it will like give us the HTML content for from the web page. And then we remove the JS and CSS codes. JS by it means JavaScript, and CSS code why? Because like those are not relevant for answering customer queries. We just need the text content, and that's why we remove the JS and CSS code. See, this is the one of the pre-processing steps. So you can like add more pre-processing steps which you want. This is just a simple version of how a basic chatbot is built. So it doesn't like include much of a pre-processing or much complex algorithm, because like that would be little hard to demo. Yeah. Then we extract text in Markdown format. We don't extract text in text format, but in Markdown format. Why? First reason is that so that information about the URLs and other metadata is not lost. Because if we will like directly convert it into text, then our like the information about our URLs or redirects will be lost, and we don't want to lose that because that's very essential information. We want to preserve that. That's why we extract the text in Markdown format. And second reason is that our LLMs do understand Markdown. Like they how like we know that LLMs such as ChatGPT and Gemini understand code text. In the same way, they also like understand Markdown. So when we like pass the context or documents in the Markdown format to the prompt, to the input prompt to use to ChatGPT or any LLM, so they understand that this is Markdown format and what they actually mean, what those hashtags and what other things actually mean. So this is the code to like convert it into the Markdown text. Then we also like extract the page metadata. So like in my case, I've extracted the very basic metadata such as title, description, and keywords. So like why do we need metadata? So that we store it the metadata into the vector store, and for faster retrieval, we store the page metadata also, because like a vector store work on two level. Like it will also like it can also search along the metadata for faster retrieval. So like first it will search for like it totally depends on you how you want it, because you will have to like set it up to search based on the metadata, but it can work that. So for faster retrieval we also store the page metadata along with the text content. So this is like the code to extract the text. So here we like extract the page title, then we extract the description of the document, because every like HTML document have a meta description. So it can be either blank if someone has not set it up, but generally people set it up for SEO purpose and other things. So that's why it works well. And these are the meta keywords. So like SEO uses these meta keywords for indexing the website or other things. So that's why you may find meta keywords also generally in the normal websites. So this consists of our web crawler. So like it takes URL as an input, and then it returns the markdown text and metadata as an output. So now we like suppose we provided it a URL, and now we have our text and metadata. So what will be our next step? Yeah. So our next step will be like cleaning the text and pre-processing the text so we can store it into the vector store. We generally clean and pre-process the text so that we remove the irrelevant information so that it doesn't get passed to the LLM. There are several benefits also of doing that. One, that you all will know that clean data is always better than unclean data. Second is that prompt size will be like a little smaller when you pass the clean data, because the irrelevant information is like removed. And we know that smaller prompts is generally output better than very longer prompts. See, here it doesn't mean that smaller prompts will answer always better than larger prompts. It will only answer bad than the shorter prompts will only answer bad than the longer prompt when you provide it with the irrelevant information. So that's why we like clean it. And so let's see how we clean it. So this is the text-to-doc.py file. So here I have written all the functions which will take text as the and metadata and will convert it into the document. By document I mean LangChain document. So here you can see. So the document just contain text and metadata. So yeah. So these are some of the data cleaning functions which I have written for the text. So like to merge the hyphenated words, fix new lines. So this is just for the showcase. In reality, like when you build a real system, you will need to code up several data cleaning functions. Because it totally depends on your purpose, what information you want to keep, what information you don't want to keep. Like in this fix new lines character, in case of multiple new lines, we just truncate it and remove multiple new lines. Sorry, this one function remove multiple new lines. So we do that. But in any case, if it is required and multiple new lines do tell a particular thing or particular concept. So in that case, we will preserve this new lines information and we will not remove it simply. So these are cleaning functions which we pass our text through, and they will return the clean data. So this is the wrapper function around our function. So this is the clean text function. So it receives the text as an input, and it passes the text through a list of cleaning functions, and it returns the text to wherever it is requested. So you can see that these are the functions which I have written for my data cleaning. So you can include more functions according to your use case. So it will pass our input text to each of these functions and will then return the output text. Now we have got the clean text. Now we will have to convert it into documents to store it into the vector store. So this is we do it by text to text function. So it receives text and metadata as an input. And what it does is it converts input text to a list of documents with metadata. Why list of documents? Because if we are passing a single document, why list of documents? Because we break our document into chunks, small chunks. Suppose our initial document was of length 20,000 words. Suppose it is of 20,000 words. So what we will do is we will split it into smaller chunks. Why? So that for faster retrieval, that when semantic search is performed in the vector store, so that it can focus on more on the specific keywords or content for what it is searching for. And also second benefit is that's the whole purpose of RAG, that we want to make the document smaller enough to fit it into the prompt. That's why we break the document into chunks. So in this case, I have used the markdown text splitter. So this is a text splitter you implemented in LangChain. So what it does is it takes markdown text and then splits it into the chunk size and chunk overlap you recommend. What chunk size means here is the document of a particular length, and what chunk overlap means that some characters will be same for the previous document and the next document, so that documents can be connected together. So that a second document is not a whole new document; it is connected to the previous document. So that's why we set the chunk overlap parameter here. Then after setting up that text splitter object, we pass our text to the splitter. And what it does is it splits the text and returns the chunks. Now we have our chunks. And what we do is we store our document and metadata, our content and metadata into documents. And then we we had a list of document chunks. So we append each document to the document chunk. So at the end, document chunks will be a list of documents along with the metadata. For each document, there will be a metadata. So the metadata is the same which we extracted. So in our for web crawler purpose, we did that. Also, there is a specific reason why I chose web data instead of document, because handling documents is a tedious task. You will have to first of all collect documents, then clean them, pre-process them, and sometimes documents also have private information. So you will have to remove that private documents. You have to filter out documents. So and also once you will have to regularly update the documents. Lots and lots of dependencies are on the document based chatbot. That's why I use the web document, because what we believe is that most questions that user asks, that user query, is generally available in the website. Because people generally show the text, show the general questions asked by the user in the website only. So that's why website data is much relevant to use in a rag based system. That's why we use the website data. So this so we receive the text to doc function, output the document chunk, and then this is a wrapper function to wrap whole of the cleaning and document conversion process. So it is the main function which we will call in our main chain. And by chain I mean when we will sum up these components. So in that time we will call this function only, get doc chunk, and it will then it receives text and metadata at the input, and then it will pass the text to the clean text function, and we will receive the clean text as text here, and then it will pass the text which is received here and metadata along with the metadata to text to docs function, and it will output at the document chunk. So we output the document chunks to the wherever it's called. So now we have our we have so we have configured two steps till now. We have got the data, and we have stored it into the sorry, we have cleaned it and converted it into the documents. Now what is the third step? To store it into the vector store. So this is in our utils.py function. So all of the functions are here only. So for chaining function, for getting the response and other things. So this is the main file which will call everything here. So now let's see what all functions are here. First of all, it is the get chroma client. So this is nothing else than it returns the chroma database, chroma vector database client to us, because we can to interact with the database. See, vector database you can understand it as a server. So to understand to interact with server, we need a client. So that's why we interact with chroma client here. So you can see that I have created a collection. Collection is a group of documents. You can create different collections. Suppose suppose in case of CloudxLab, I have two types of document. One is sales data and one is tech data. People ask tech doubts. So I have two documents. So I can create two separate collections for that. That one is sales data and one is tech data. And what I will do is when a user's question will come, I will create a pipeline such that it automatically detects whether the which collection needs to be retrieved. What it does, it helps a little by segregating the data. Now all your data is not in the same place. Second place, it lesser the data, faster the retrieval. Even the vector stores are built for that purpose, that you can store large documents here, but still smaller they are and better the faster the retrieval will be. That's why we can create different collections here. Then we use the embedding function. So the big to amp the documents. So here we can see that I have the OpenAI embedding, which we think is the which is a very good compared to the other industry embedding. You can try that, or you can try other embeddings too, according to your purpose. And then we have to define the persist directory, where your data vector database will be stored. So I store it into the data chroma. So you can see that this is the folder and this is the document which is storing my everything. And internally it uses SQLite database, which you can see here, chroma data SQLite 3. So it uses SQLite data internally. Yeah. So now this will return the chroma client. Now this is the main function stored up. So what it does is it will retrieve it takes URL as an input, and it will retrieve data from a website, process it into document chunks, and store them in a vector store. Yeah. So this is how it does it. Like it will first get the URL and then call the get data from website function from the web crawler. The web crawler we implemented. It had the function get data from website, which takes URL as an input and output text and metadata as the output. So we will first call that function, and then we'll pass this text and metadata to the get doc chunks function, which we discussed in the text to doc file. So what it will do is like it will take text and metadata and will return us LangChain documents. Now our task is just very simple. Just initialize a vector store. We do that using get chroma client, and get chroma client will return us the vector store. Then we just add the documents which we receive, and then at last we call the persist function. What persist means is that these changes are permanent, not temporary. So like in case we are just doing trial and error, trying different new things, in that case we will not call the persist function, because we want to change it temporary. But in case our changes are finalized, that yeah, this is the pipeline which we want, this is the process which we want, in that case we will use the persist function, that these are the permanent changes, and store the document permanently in the database. So now like this is the now our this is like first step of the RAG is complete, that storing the documents into a vector store. Now we will be using these documents to answer the customer query. How we will do that? Here comes the LangChain main, the main thing which for which main functionality for which LangChain is used to chain that LangChain provides the functionality to chain different like components. See, we need a several components to build a LLM powered chatbot. Like one we discussed, we first need a vector store, then we need an embedding, then we need a retriever. What retriever does? Retriever retrieves the documents from the vector store. So LangChain provides the functionality to chain them all together so that they are all not scattered. So that's the main functionality of the LangChain. So here we will create a chain of LangChain components to answer user's query. Yeah. So first we will initialize our LLM. So in this case we are using the chat OpenAI function. So here you can see that the model which I am using is GPT 3.5 Turbo. There are other models too, GPT 4, so you can try that also. But temperature here, I mean that randomness. See, in chat, like in LLM, there is a parameter called a temperature. We need to tune, like it is generally between 0 and 1. So 0 means that there will be no freedom to the LLM. So it will output always the same response, like nearly the same response. And in case the temperature is 1, in that case, it has like a lot of freedom, and it can think a lot, and it can improvise a lot. So in that case, it will it can output different results for the same user query. But in our case, we are setting the temperature to 0, because our we don't care about whether the response is response is very unique or not. Why? Because our task is just to build a chatbot that should efficiently answer the customer's query. So that's why we choose that temperature equals 0, so that it only answers the exact answer based on the exact document, and it doesn't think on its own. So by tuning the temperature parameter, what we are doing is we are giving the privilege to LLM to think on their own. So now in case we are building something other some other functionality. For example, we can say uh, a tool that can write blogs or article. In that case, we will tune the temperature higher, maybe between 0.5 or 0.6. Why? Because in that case, we want it to generate good context, and we want it to generate think on its own. So in that case, we will tune the temperature parameter. So this is our LLM which we will be using, and this is the vector store which we will be using. And this there is also get prompt function. So what it does is it will give us the prompt, and also let's see the prompt function also. Prompt is the input which we will pass to the LLM. So here is the get prompt function, and let me just yeah. So this is the prompt which we will using to pass to the LLM. So you can see that the prompt is URL support agent at organization name. So organization name I will pass in the Go. Organization info, that what your organization is actually about. So this by experimenting several things, we found out that providing an description of the organization about what it is actually about, what are its product, what are its services. It actually the LLM generally answers better queries. So this is our prompt, that your task is to answer customer queries, and you can like tweak this prompt to see which one better suits your purpose. Then we like also provide the ways to contact company support is like here you can provide the contact info, so that in case that LLM doesn't know an answer, it will just simply say that I don't know the answer of this. You can kindly contact their email or phone number, whatever contact info you provide. You can also provide the link to your link to your contact us page, anything which you want. Now we will like this is our main prompt, that this is your task which you have to do. Now we have now I've like included use the following pieces of context to answer the user's question. So by context here, this is the context parameter. So here documents will be stored. The documents which will be retrieved, here it will be filled. And then also I have part the chat history. So like I have not implemented the chat history yet, but like in case if we want to implement it in future, so we can directly like pass the chat history also here, so that user like LLM remembers the previous conversation. So like so that by passing the chat history, we can provide more of a conversation type field, not an individual response. Like see, when you first invoke an LLM with a query, it will answer your query. But when you second time also invoke the LLM with the query, it may not like no previous contact or previous conversation. So to fill up that gap, we pass the chat history and then the follow-up question. So we will pass the follow-up question also here. So LangChain provides the prompt template that we can use. So you can see. So here I will use the chat prompt template because this is more of a because we are building a chatbot. Then chat prompt template further consists of system message prompt template and human message prompt template. Why? Because LLM like understands system message and human message differently. System message are more like an instructions to them, that yeah, these are my guidelines and I should adhere to them. But human message are like more of a these are not instructions but a query. That's why like we provide this, so LLM knows better what are the instructions and what are the query. So this is the chat prompt template. So you can explore it in the LangChain documentation. So now after receiving our prompt, we also need a retriever. By retriever, because the retriever will be the one which will retrieve the documents based on the semantic similarity between the user query and the documents. So here, like I have initialized the vector store backend retriever. There are several other retrievers provided by LangChain. This is the most simplest one among them. So you can try out different retrievers in their documentation. Here, search type I have used MMR. So MMR is an algorithm which is like maximum margin retrieval. So what it will do is like what MMR will do, that it will like first search along the document, such like first do a semantic search based on your user's query and the document, and it will then also filter out the document that is the document which are filtered does not contain the same content. So in that case, like you bypass that the same what in case that two documents are there and they contain the same information. So in that case, like we use the MMR so that it does not like retrieve the same document twice or similar document twice. So new information can be passed to it. There are other search algorithms also like similarity score based, so you can try them out. Then we like chain all these components. So like this is the conversational retrieval chain, which is like generally used for building chatbots. Yeah, here I part the model, the LLM, then retriever, and then I also want that you return me the source document, the document which you use to answer the user's query. So I will like return like get those also. These are the parameters which we just pass to it. So here I pass the prompt the prompt which I want to the chain, and then refresh question is just a conversational retrieval chain specific parameter. What it does is like it will not see, we know that conversational retrieval chain, like we also pass the chat history to the LLM. So in that case, what a refresh question will do, it will like rephrase the question, the user's question according to the chat history. But here in so it we generally keep it true in production, but here we are not using the chat history component. So that's why we will we are keeping it to false. So even if you keep it to true, it will not rephrase the question because you do not provide any chat history. Now this is our get response function. So it will take up the user question, all the metadata which we need, organization name, organization info, and contact info. Then it will we have initialized chat history as empty here because we have not implemented it. Then we chain all these, we call the make chain function, which return the conversational retriever chain object. And then we just invoke this chain, or I can say, I can say run this chain. So you can see here that the chain, I pass the question, chat history, organization name, contact info, organization info, and then LangChain automatically fills it up. But it doesn't automatically fills it up. I provided the app strings here for each parameter, so it fills these app strings with these things. So now we have completed our RAG based system. So what we first did was we stored our data into a vector store, and then we also built a chain that can answer a query. Now let's see it in production, how it will work. So you will also have to set up the environment OpenAI API key environment variable to for the LangChain to work or LLM to work. So here I am doing the same thing. I am loading the environment file and just setting the variable. Now I will import all the functions which I will need here. So these are the functions which we just implemented: store doc to store the documents into the vector store, get response to get the response, get chroma client to retrieve to get the chroma client. So I will be using this web page to showcase it. Let me first someone in YouTube chat has asked you use ChatGPT for coding. Yes, for some code I asked, not for complete code, but yeah, to implement a specific functionality. More on the when I work on the website front end and back end. In that time, I use ChatGPT for coding. Yeah. So this is the our course page, the hands-on generative AI with LangChain and Python. So it is also for generally for beginner. So you all can explore this course for it. So we will build our chatbot around it. So when we will store the documents about this web page, so it will be answer, it will be able to answer each any question which is stored in this web page. I will also paste the course link here so you all can refer to it. Yeah. Now let's run the store docs function and let's see what we receive. So we'll first have to import these functions to use it. So I have done this code before. So till the function gets loaded, I don't know why it's taking too much time to load. But yeah, let me show you how the document gets stored. So for the whole from the whole web page, the total number of the document chunks which were made were 9. So there was a single web page which we part, but it split the text content into 9 documents. So this is how the content looks like in you can see hands of generative AI. This is the and this is the metadata which we were talking about. So you can see that this is the description metadata which we were talking about. Embark on a transformative journey into the realm of. So you see that it also informs like stores information about what the document is about. Yeah. So our that YouTube function is loaded. So let's call it again. Uh, like once you have stored the documents, it's generally not recommended to store the same document twice. That's why I deleted the documents from the vector store so that I can showcase it live. So now our store documents is running, and it will be it will first call the crawler, and then it will receive the text and metadata, and then it will clean and pre-process the data and convert it into document, and at last it will store it into vector store, and so our documents get stored. Now let's see how our documents look like. Yeah, so this is how our look like. So you can see 9 are there. So you can see the content is same. Hands-on generative AI with LangChain. Imagine crafting your own GPT from scratch or building a chat agent. So this is the same content as the content displayed on our web page. You can verify it also. This is like a number of documents. So we have 9 documents, and this is how metadata. This is how embeddings look like. So you can see one embedding vector is of like 1536. So this is a embedding vector of a particular document. Yeah, 1536, we are embedding a particular document. So this is how our embeddings look like. Now, like we have our vector store setup, and we have stored the document. Now let's get the response. So let's ask with a very basic question: what is the duration of this course? Let's run the response. So yeah. We get the response. The duration of the hands-on generative AI with LangChain and Python course is 2 months. It is a live training course where you will have access to CloudxLab for 60 days. During this period, you will have the opportunity. Now, why it's like I only asked for a simple question. What is the duration of this course? But it is also added several things. Why? Because I have written my prompt in such a way that you should always talk good about and show organization and show it is the best in the industry and customer is doing best job in its life by purchasing its product. That's why it is adding this additional info due to my prompt. So now you can also see the documents which were retrieved for the purpose. So this is the our prompt. You are an expert support agent and cloud. So after filling up those app strings, the parameter, this is how it gets stored, and this is the contact info which I was talking about, and so use the following pieces of context. So in this case, we are retrieving a 4 document. So this is the first document. This is the second document which is retrieved. So you can see that here it's mentioned 2 months live training. That's why it retrieved this. And this is why it retrieved it. And as I'm using MMR as the retriever, so that two document doesn't contain similar information. And also this is more of a only 9 documents are there, and in that we are retrieving 4. So that's why this document is not similar, but still it's being retrieved. In case of larger systems, when we will have thousands and thousands of documents, in that case, it will only retrieve similar documents, the things which actually contain the answer. Now you can try out different questions. Who are the instructors? So here it will answer Sandeep Giri, all about the instructor. You can also will this course cover RAG. So yes, this course cover RAG, and as one of its topic, RAG is it also gives info about what is a RAG. What are the prerequisites of the course? So the prerequisites of the course are background and basic probability and algorithmic thinking. So maybe it's in the website there only. Let me see. Yeah, so it's mentioned here, but these are generally not required as a prerequisite for this. And you will only need a basic of Python knowledge for this. And like even if you don't know Python, then also like we will provide you self-paced content for Python, which you can like use to learn Python. So this is our like what how we can build our end-to-end rack-based system. So we can see that we coded our rack system live. We like started from the crawler part and cleaning the text, and then we like converted it into documents, stored it into the vector store, and then we also like show how we can get the response from the vector store and LLM, and these are how documents are retrieved. So this sums up our like more general of the purpose. You can refer to our like this course if you are like want to work for generative AI. This course is like for absolute beginners. So if you know Python, it's better. If you don't know Python, then also like we will provide you content for that, so that you can learn it. This course is like generally for engineers or people who are interested in tech, or people who are for manager level who want to like learn generative AI, so that they know about AI too. Let me also guide you to the like little basics of what we will cover. So we will provide you three self-paced content. One is for Python, one is basics of ML, very basics and one is for building end-to-end ML projects, so that you know how an end-to-end ML project is built. Then we will start with live classes. So in live classes, we will start with how basics of how does a machine learn. So that's the first thing which you will like learn when you will in the live classes. So we will introduce the neural networks and its working. Then we will introduce the natural language processing, that how model generates word and what are the applications of natural language processing. Then we will jump into word embeddings like in much detail than we ended up into embeddings in today's lecture, and like how machines represent word. Then we will cover GPT and how it's trained, how like we will also code our GPT from scratch, and then we will you can see that we'll discuss everything. And this is like best part is that this is an hands-on course. So like we will cover all these, like it had 10 plus live projects. So these projects will be covered in live classes, that building your own GPT from scratch. Then we will cover ChatGPT, prompt engineering, vector databases, LangChain, also stable diffusion for image generation. And then we will show you how to work with Gen AI with the common like APIs such as GPT, Gemini, DALI, Whisper, Midjourney, etc. These are the live projects regarding the APIs you use only. And then at last, we will cover the use of common AI tools for automating daily tasks. So you all can pursue this course if you want. Yeah. So now let me take questions one by one. So there is a question: should we also install Chroma in the system? Yes, Guru. You will have to like install Chroma to for the LangChain to work. That's why I installed Chroma DB. So you can just clone the Git repo and just run the pip install r requirement.txt, and it will do the work. And what was the other question? Order the Chroma what's your opinion on using Hugging Face? Hugging Face is like a very good platform if you want to try out different models. Like it has lots and lots of models, lots of projects which you can try out. And I will like recommend you can explore the Hugging Face to like see what all things are are happening in AI field. Now let me take questions one by one. Just wait a minute. I will. Oh, so attendance link has not been shared. So let me share it. So Sachin has joined us. Sachin, please share the feedback form link in the chat window so people can fill. Yeah. So let's go to the doubts one by one. So is this meeting for this topic building a custom chatbot? Yeah, Milind, that's the topic which it was about. Yeah. Now, okay, I forgot to will it go through subfolders or other thing? So yes, it will it can go through subfolders, so you can code it. I just forgot an important part to discuss that I will discuss now. Okay. Yeah. So what is the further work? You can improve the crawler to crawl whole sitemap and store it in vector store. You can also add the functionality to crawl recursively or anything you want. So that totally depends on you. And then you can also automate the web crawling process. That it automatically checks when the document is updated, and it automatically updates the documents in the vector store when the web content is updated. So these are the further work which you you can understand it as a homework for you, so that you can learn the pipeline better. Yeah. So how do we get certificate? So for if you are asking for the webinar certificate, so you will have to fill the feedback link, which is just shared by Sachin. So you can fill it, and then you will receive the certificate. Which ID is you, dear Martin? I am using VS Code, so you can try it. Yes, Payal, it's a 2 months course, and the classes will be three times a day. Generally, uh, I'm not sure, but most probably Monday, Wednesday, and Friday will be the classes. But yeah, either it will be Tuesday, Thursday, Saturday, or Monday, Wednesday, Friday. Most probably it will be Monday, Wednesday, Friday at night, 8 to 10 a.m. IST, and you can convert it into your time zone according to in IST it will be 8 p.m. to 10 p.m. And you can connect with me and Sandeep by LinkedIn. I will pay. Okay, I will paste the LinkedIn profiles once I cover all the doubts. Any special offers for old CloudxLab students? Yes, Martin. There are always special for our alumni because we respect them a lot. You can reach out to our sales team using the contact button, contact information provided in the course page itself. So you can use that to contact them, and they will guide you through all the offers for our alumni. Will this video be saved? Yeah, Mark, hi, Mark. So yeah, the video will be saved, and once you fill the attendance form, you will receive the video and the presentation too. Thanks, Lee, for your kind words. Any course on AI agents as well? Yes, Naveen, this course covers AI agents too, like implementing your own agent. And we also have project, live project, which will cover on creating an OpenAI agent for your automating your daily tasks. So yes, Naveen, that will we will cover that part too. So Sachin can classes will be on Monday, Wednesday, and Friday. Thanks, Sachin, for confirming that. Now, can we get this notebook? Yes, you can okay, let me paste the repo link and you can perform those directly. So, I have pasted the repo link in the chat window. So you can refer to it. How do we protect our OpenAI API key value for production environment? Storing an export does not seem safe. That's why I have created a separate file environment sample.sh, and I just added that our my main environment.sh file in git ignore, so it doesn't get pushed over there. And there are several there are several ways which you can provide more. Of the more of the privacy and security. So you can store it in a different file, or you can even encode it according to create using pre-recorders pre-encoders, or you can also build your own encoder. That totally depends on you. In that case, you can protect your OpenAI API key. What we generally do is we create a separate file for our personal use, and a general file which where we add all the variables. Wait a minute, I can. Yes, Sumangi, you can create chatbot for any website. Like you can pass any web URL here, and it will create. Even like some websites have a privacy like that. You will have to log in, log in before to access the content. In that case, also you can create the login session using the crawler itself. So you can like there is simple functionality. You can just search in or search it on Google, and you will find the code to like how to create a login session. In that, like you can do everything with crawler. So yeah, we can crawl any website, and like you can also see, this is the basic version which I have shown you. Now what you can do is like you can implement it for sitemap, so that it takes sitemap as an input and crawls all the URLs inside it, because like all the URLs of a company are stored in its sitemap. So our like task, our agenda was not here to discuss about crawling. It was to discuss about track. That's why we did not focus much about that. So yeah. If you have Python, you can use the same command Python 3 space dash m, and when with the tool which create the virtual environment, and then a virtual environment name which you want. So look at you can use the steps. So this tool is for creating a customized chatbot using website data. How about a customized data using files in my internal computer network? So there is that's a very good question, Larry. So in that case, there are functionalities in LangChain itself that you can upload your documents as PDFs or other formats too. So you can explore that documentation on how you will do that. Only the process of getting the text will change. So text to docs, see our text to docs function, which we implemented to receive the text from the crawler, that will still receive the text only. The only portion which will of the code which will change is the way we are providing the text. So in our case, we were using web crawler for to provide the text. But in case you want to implement it for PDF, you can do that too. Where I begin to without using any cloud services, you can like use LangChain, Llama Index for the purpose. Larry, what if my the website contain links to other documents? So in that case, if you don't want those links, then in that case you can like remove those links. Otherwise, what I did once was to like added a functionality so that it can recursively crawl through the websites, so that we can have more information. So it's a like a very risky thing, because it can recursively go into a loop. See, it will for once crawl the websites of a web page, and then it will further like crawl all the website listed in this web page, and then it will again crawl the further website listed in the other web page. So that's why it will be a recursive process. So it can cause a recursion loop if there are lots and lots of links. So you can you it totally depends on your purpose, like what you want. During the course, will you provide the lab with a Python environment? Yes, Martin, we will provide you with a lab where you can practice LangChain and other like concepts. You could use web-based loader. Yes, Ogita, that's a very good suggestion. You can also use Selenium or other Python libraries for the for web cloning part. So you can clone the project and implement the web-based loader and see how it works. Do you have to install Chroma as well? Yes, Gurunathan, we have to install Chroma. What is good or bad embeddings? How are embeddings generated from different models or compare? As it was mentioned recently in chosen that OpenAI embedding is better than other. Yeah, so that's a very good question. See, there is nothing like a good or bad embedding. Like each good embedding. If we will still have to classify our it into the good or bad embedding, what I can say is like good embeddings are the embeddings which capture better the semantic meaning of the sentence, and bad embedding is which fails to capture the semantic meaning and syntactic semantic both meaning of the of the model. So that's how we'll compare the good or bad embedding. So yeah, there are trademarks in the way that we compare the LLMs that for now Gemini Ultra has passed. So there are benchmarks for comparison. So you can explore those benchmarks suppose like Gemini has recently surpassed ChatGPT on some benchmark some benchmarks. So it doesn't mean that Gemini is better than ChatGPT. On some aspect, Gemini is better than ChatGPT. On other aspect, ChatGPT is better than Gemini. So you can explore both, and you can research it on the internet, and you will find it, Manan. Which function does the embedding? So I use the OpenAI embedding, which you can see it in the code. When I am making the chain, I am initializing the OpenAI embedding. So Sanjeev, you can do that. How much to pay for this course? You can refer to the course page itself, HP, and the course fees and other things. All our things are mentioned here. How can we connect with you and Sandeep ji? I will shortly provide you with the LinkedIn profile of both. Uh, Thanks for your kind words, Shigit. How do we take participation certificate? You will you will need to fill up this attendance form which is shared by Sachin, and once you fill it, we will you will receive the certificate of participation, the recording of the session, and also the presentation used. Any course on AI agents as well? Yes, Naveen, I guess this has been already answered. This course covers AI agents also. Like chat dev, if you know, it works like small agencies. Like chat dev, if you know, it works like small agencies where each role is. I don't know about chat dev, Naveen. Sorry. I will surely look into what chat dev is. Could you kindly provide the social media links? Yes, we will. I will surely provide it shortly. If there are slots for course before 8 or after 10, you can contact us and we can discuss what we can do for you. Yatendra, you can go to the course page and contact our sales team. You can you can directly mail us also at reachus@cloudxlab.com, or you can you go to the course page and could dial our number also. It's mentioned there, so we can discuss it, Yatendra. Will this course be on CloudxLab, or I need to have any you will not have to do any installation on your side. Everything you will be able to practice on our lab itself. So that answers your question, Naveen. What type of security guidelines can be used for safety? Uh, that's a very good question. One for I don't know your name. Yeah, so that totally that again depends on our specific purpose, how do we want it. Like suppose I want to keep some data private, so see, most of the data filtering, sensitive data protection and other security guidelines are implemented manually by us. We either write a code for it, or we do it manually. But because see, security guidelines generally depends on these are generally different for each company or product. So that's why there is not a set but yeah, all LLMs or chatbot must adhere to the legal safety, so that they don't violate any law. So ChatGPT and other LLMs are trained so that they don't violate any law. When they were first launched, they did violated some of the laws by answering questions which it should not answer. But over the time, it has improved a lot, and now they are generally don't pass of the legal info. Rabindran, for fees you can Ravi Narayan, for fees you can see the course page. Yeah, Mushroom. So as I have answered that if you're you can also create the login session, that if your website is secured with credentials, you can create the login session. So what you will have to do, you will have to create a account on that website, and you will have to pass that user a username and password to the web crawler. And once you have created a login session, then you can use that object. You will get a response object of that login session, so you can use that object which will act like you, as you are interacting as a login user. So it will act in your place and crawl all the websites. I see, Navya. I see companies also looking at Microsoft Copilot that integrates in Microsoft Word, Teams, and other Microsoft environment. We will also get a glimpse of using those tools. Hmm. We can discuss that. If you want to understand it, we can see. We will generally you introduce common AI tools. So that can include Microsoft Copilot, GitHub Copilot, or other AI tools, AI things which have done great innovation. So yeah, we can discuss that. How can I get concession as I am already a registered candidate of Cloud? Jagdev, you can contact our sales team for that, and we can discuss on that. As I have already told, we offer we value our alumni, and you can contact our sales team. Is Python enough to create a chatbot? If yes, how much do we need to know? So, right now, I have quoted the chatbot version. So you can see that all the libraries which I used were Python libraries only. So majorly, I just needed Python. See, even if I work in ML field, then also these libraries such as LangChain and ChromaDB, these are new for me. So for understanding them, I have to know Python. So you can have an intermediate knowledge on Python. Like you don't generally about the oops concept and very basics loops and other things. So you can you need to have that knowledge on Python. But if you join our course, we will also provide the self-paced content for Python, which you can you refer to learn. How to train the LLM for multiple web pages of a same organization. That's what I told you, that you can count it as a homework, that how like that to give it as a sitemap of the whole organization, and it will recursively crawl all the URLs from the sitemap. That's not a very tough job, it's very easy job, and I guess you can code it in 1 or 2 days. What about the fees? You can see about the fees on the course page. Thanks for your kind word, Indu. Thanks very much. Let me also share my LinkedIn and Sandeep's LinkedIn. I pasted my LinkedIn. Let me paste Sandeep's also. Sandeep's LinkedIn you can also get by directly searching Sandeep Giri on it's LinkedIn. But let me give you the exact URL. Hi Naveen, you can contact our sales team for that, and they will be able to guide you better on our on that part. By the way, you can also find the LinkedIn's in the course page only. Yeah, so thanks Sachin for providing the LinkedIn. And you can also find the LinkedIn of me, Sandeep, and other instructors in the course page itself. So I was working on chatbot to ask as an interviewer I told it not to prompt help, but it kept doing it. You will have to master prompt engineering skills for that. So you can refer to OpenAI prompt engineering guide on how to provide strict instructions to the LLM. You can also join our course, and we will also cover that part also, like prompt engineering part. So yeah, had this course already ended? Yes, no, yes, it the course this was not a course but a workshop on building your own chatbot. So yeah, it has ended. Okay, so I guess doubts are over. Let me also see the YouTube chat window once. Hi Nabil, yeah, you can directly search it on oh, you can refer to LangChain documentation. They also provide functionality or demo code to how to store PDF documents. So you can refer to LangChain documentation and you will find your answer there. How will you cover crawl websites that are user ID password for that I've already answered that question, Guru. So will you cover LangChain in detail? No, yeah. So, or there are separate course for LangChain. So, yeah, we will cover LangChain in detail, and we will most of our projects are using LangChain only. So, when we will build those projects in that way only, these will be live projects, and you will work with us. So, because these will be very hands-on interactive projects. So, in that case, you will be able to learn better about LangChain. So, yeah, we will learn LangChain very better. How will we get recording? The course link and LinkedIn info is are there in the chat window itself. So let me once again paste it. I guess course link got lost up. I have again pasted the course link there in the chat window. So you can refer to our course. LinkedIn is just above the course window. And Sachin has again shared the attendance form. So you can fill it to receive the certificate of participation, recording, and other stuff. So it was a very great session today, and the questions you all asked were really really good, and they were really good, and that showed that how interested you all are. So yeah, so that's it from our side. So yeah, thank you everyone for joining. Have a good day or night if you are in India. Bye everyone.